All right, so when we have all these numbers, we have to organize them into what we call sets. So what we're going to talk about in this lesson is organizing real numbers into sets. There are a lot of numbers in the world, and we like to organize them all into what we call sets. One of the biggest sets of numbers that we deal with is called the real number set. For now, just about any number that you can think of would be in the real number set. Graphically, we can represent this with a number line. This is an example of a real number line. We start with 0, and we use integers going out here to the right, positive numbers, and to the left, negative numbers. Now, from our set of real numbers, we can break those numbers into two basic groups called rational numbers and irrational numbers. We can go from there and break down the set of rational numbers into smaller sets of numbers called integers. Integers are both negative, 0, and positive numbers that you typically see labeled on the bottom of a number line, like the previous slide represented. One step further, we can break down integers into sets of numbers called whole numbers and natural numbers. You can see this represented in this chart here. We have irrational numbers. These are kind of crazy numbers, square root of 5, pi. These numbers typically will go on and on and on without repeating, and their decimals never stop. And then we have real numbers over here. These typically are the numbers that we use quite a bit in math. Now, besides all the sets discussed earlier, we want to look at other sets of numbers. Many solutions to problems we do are sets of numbers. For example, x equals 3. It is a set of number. A set of number that just contains one number, one solution. X is greater than negative 2. That would be a set of numbers. Or even all real numbers. Those are sets of numbers. There are several ways or notations we can represent these sets of numbers for our solutions. One way is to use inequalities. This is pretty common. Using inequalities to define the set of numbers using less than, greater than, less than or equal to, and greater than or equal to. There's also something called interval notation. This is where you use brackets to define the set of numbers using rounded brackets, left side, right side, or square brackets, left side, right side. Another common way to represent a solution is graphically, using a number line to define the set of numbers. It is important to know that you may be asked to represent your solution different ways, using a variety of methods. Sometimes you will have one solution or many, and there are times a graph will be the best way to represent your solution. Take a look at these different examples. We have standard notation where we're using greater than, less than, greater than, or equal to, and less than or equal to. Here we're making different statements for a solution. Now we are looking here, graphically representing those solutions. And then here we have interval notation, where we're using brackets, rounded brackets, and square brackets. Notice that if we use rounded brackets, we don't include the endpoints, negative a. We're not including them in our solution. When we use square brackets, we do include those. We fill in the negative a and a, and it would be less than or equal to or greater than or equal to. So we have all sorts of numbers. We need to organize these numbers into sets, and we have different ways to represent those sets of numbers. Thank you.